Welcome to SolarWorks for Illinois. I'm Tim Montague, your host. Today is May 7th, 2020, and we are joined today by Tim Sylvia, Associate Editor of PV Magazine. Welcome to the show, Tim.
Thank you. From one Tim to another. Thank you for having me on.
It's great to have PV Magazine journalists on the show, so I'm grateful for your time. And what triggered me reaching out to you was you penciled a nice article on solar safety and fire safety on PV systems back in April. PV safety, of course, is something that you don't hear a lot about. Usually PV is something that goes on your roof or on your ground and you set it and forget it, and it's out there day in, day out, doing its job, converting sunlight to energy, producing clean power, and it's a wonderful technology. Solar PV is mature technology. It was invented in the 50s, and so it's had 70 years of maturation now. But problems do occur, and we want to talk a little bit about how to avoid problems, what are the potential problems, and what are some of the technologies that O&M companies and individuals are using to detect potential problems in PV systems. So let's dive into that. So Tim, tell us about your story and what's going on with fire safety.
Right, yeah, so that story kind of came to be because we've always had a contact with Lawrence Shaw, who does high power PV that's in Arizona. So if you want to talk about somewhere where there's concerns about fire and there's a lot of PV, you know, if you're not thinking California, Arizona's right up there too. And we had worked with him previously. Actually, John Weaver had worked with him on a similar article. And Lawrence has taken it upon himself to become sort of, well, you'd have to ask him if he thinks he's the foremost, but he is the PV fire expert in my eyes. And what he has done is he has tracked all the fires since 2015 that have been traceable through the U.S. Fire Administration to solar projects, which in and of itself was no easy feat because solar PV fires or any sort of thermal event related to a solar system isn't categorized by the U.S. Fire Bureau or Department as its own thing. It's just kind of mildly classified under other causes. So he had to actually go into all their data and dig around and get the ones that he could specifically identify to solar systems. And what he found was that the majority of the fires not only were in California and Arizona, but, and it's not a hard majority, slightly more were on residential systems. And he was kind of the opinion that a little bit less O&M goes on these residential systems. And like you were saying, there is kind of that set it and forget it attitude where, okay, these are going to be up here, these are going to be generating, like I'm going to save money on my bill, this is great. But there is definitely still that need. Like you said, this technology has been around since the 50s. It's obviously been updated since then, but just because it's old doesn't mean, you know, it's perfect. Like we've had cars since the turn of the century, but engines still fail, like things still happen. And so he's been a really heavy proponent, and I see his point on infrared imaging to detect hotspots that could lead to thermal events in O&M, yearly O&M reviews of systems. And I mean, even at the base level, just checking in on systems every year to make sure everything's working as it should be.
Yeah, I mean, obviously the main way that we know what a solar system is doing is by looking at the kWh production of the system relative to what is expected. And so I would encourage everybody to be regularly monitoring their systems. Most systems do come with some kind of a monitoring system so that you can just look on a sunny day where your production is or where your production has been for the last month or two, and then just keep an eye on that. And but these hotspots, so as modules age, they're out there in the sun. They are semiconductor technology, and they are slightly degrading at about 0.5% per year. And problems can occur in the modules. The module failure rate is very low. It's like 1 in 1,000 modules might have a potential failure. So that's very, very low. But if a problem does occur in a module, there are these phenomenon called hotspots, where resistance builds up. Maybe there's a conductor that breaks. Some of these conductors are very small, right? Let's say a hailstone hits the module. There's no obvious physical damage, right? The modules are designed to withstand hail strikes, but it caused a small crack. And then over time, that crack grows because of the second law of thermodynamics, right? That just everything tends to disorder over time. And solar arrays are designed to to last for 25 years. So they're up there for years, and a decade goes by very quickly. And so if a hotspot occurs, then literally you are getting some heat building up in a particular point on a module, and that could cause sparking or fire.
Yeah, absolutely.
And what eventually can happen is rooftops can catch on fire, solar arrays can catch on fire. And this gentleman you mentioned, Lawrence Shaw, he documented 155 rooftop fires around the country. About 60% of those were residential, 40% on the commercial side. Just to put that in context, we have over 2 million solar installations nationally now in the United States. So it's less than 1/100% of the projects that are having these types of problems. But we do want to caution our owners and operators that regular O&M is a must. Even though it is set it and forget it, you want to have an annual check to make sure the connectors are all tight, that there's no wires that are fraying. A squirrel could go on the roof and chew through a wire, and that could potentially cause a problem down the line. And then, of course, there are these things with the modules. Infrared scanning, let's talk a little bit about that. That's not something that is certainly common yet in the industry. It is starting to be utilized, but how does infrared scanning work, and how does it detect these problems?
Well, as it's been told to me, is that it takes an entire image of the surface of the installation, and through that it can detect any sort of abnormal thermal activity on the cell itself. And I'm not really the expert necessarily on how the imaging works. I just know it's something that utilities all over, and specifically he talked about Arizona Public Service, have identified as something that's vital in terms of annual or however often maintenance on systems, to the point where APS does it on all of their system reviews for larger systems that they own, and even some smaller commercial and residential ones. So it's a technology that has been kind of accepted by the industry as, it's definitely helpful. It can help identify these things, these issues, but at the same time, there hasn't been a movement towards any sort of standardization for it, for reviewing projects, or even,
Right.
widespread usage. It's more on the utility or who wants to do it.
Yeah, my understanding is you take a thermal camera or an infrared camera, and you can fly that over the array with a drone, or even just a pole and walk the array. So there's various ways of getting the camera to the solar array. And then you're analyzing that with special software, which is designed to identify these abnormal, you can see these hotspots when you do look at the images with the naked eye. But of course, it's if you're dealing with a large scale system, then you're going to use a piece of software to identify those hotspots. And then you simply go in and see what's going on, and potentially replace the module or the wiring if that's the failure point. Whatever the problem is, it can be replaced and fixed. So the other thing that's relevant to this, I guess, is NEC 2017. There is a phenomenon called rapid shutdown, which is a safety code which requires certain technologies to be integrated into solar arrays. This has to do with the inverters or other power electronics. And so there's this advent of bringing power optimizers, for example, into solar arrays, which allow us to see down to the module or the 2-module level what's going on in terms of power production. And on the one end, or on the one side, this is great because it gives you more granular visibility into what is going on at the module level, and it gives you this ability to rapidly shut down what is going on with an array at any point in time. If there is some problem, then you can quickly shut off the array down to the module level.
Mm-hmm.
Now, the double edge of that is that then there are many more electronics going into the array, and there's many more connectors involved in the array. And frankly, this is a double edge. So the industry is evolving. The industry is trying to become more rigorous and safer overall, but that means more equipment. It means more labor involved in the installation. And so the installation costs are higher, which of course get passed on to consumers and project owners. And that can be a challenge.
Yeah.
So what are you hearing about NEC 2017?
So my main point of contact for NEC 17 has been Richard Baldinger of Fronius, and obviously Fronius, the inverter company.
Yep.
And he is, it's been mandated in California, which has been his big concern, and he is not necessarily a fan of it because it now doubles the amount of connection points that are being had on any sort of installation, because you have to have that module level shutdown. And not only is that adding singular components that could fail on a now doubled scale, but like we said, as much as solar technology it's good, it's great, but it's not perfect. It's the same thing with the people who put these systems in. No one actively goes out and wants to do a shoddy installation or whatever. But once you're doubling the amount of components and doubling the amount of things that go into a system, you're kind of setting yourself up at some small level for an increase in failure just by, if one connection is put in poorly or doesn't quite reach or has one small failure, it's another part of the system that wasn't there that could fail before that now can do so catastrophically. So I know for that reason, a lot of people who've been involved or who work in, NEC 17 areas aren't the biggest fans of the policy.
Yeah, we have NEC 17 in Chicago. So all of those new installations have to meet those code requirements. And the way that we meet that generally is by using power optimizers. And SolarEdge is a leader in this. Tigo is another manufacturer that makes power optimizers. And then you can use pretty much any string inverter if you're using power optimizers, and it just gives you more granularity, both from a monitoring perspective and also a rapid shutdown perspective. And just to explain for our listeners, one of the potential challenges with this technology is that the optimizer is being plugged into the solar array with a connector, literally just bringing two wires together like this, and voltage is running through those connectors. And so if that connection isn't solid, it can fray over time, and then you can have failure, just a lack of connection, or worse, which would be like sparking or a heat event. And so the moral of the story is operations and maintenance. If you own your solar array, you want to do regular O&M, what we call operations and maintenance on that. An annual checkup where an electrician is coming out, measuring the resistance in the wires, making sure that all of the conductors in the array are healthy, that there's no fraying, no thermal events happening. And then thermal scanning is kind of at the extreme end of that. We don't see a lot of requirements for or requests for thermal scanning yet. I think it is a segment of the O&M that is going to grow, especially for larger scale installations. Like you mentioned with the Arizona Public Utility, them using it on their larger facilities, that makes great sense, right? Because you don't want to have a failure in your solar array, especially if it's a grid scale power system, which might impact other aspects of grid operation. And I know an installer in Arizona that was doing some reparation work on a large array that caught fire. It was a ground mount array, and something like 10,000 solar modules got burned up in this fire. So these fires do happen. It's counterintuitive, right? Because the solar module is metal and glass and silicon primarily, none of which you think of as being very flammable, but modules can burn.
Yeah, absolutely. We just had the, what was it, 2 weeks ago, the fire on the Amazon facility in Fresno.
Yeah, I saw that in the news, and both Amazon, Walmart have been in the news in the last 12 months with solar fires. And again, it can be problems with the equipment that's being used. It can be a problem with how it was installed. If the installer was cutting corners, that's another area to pay attention to. Some owners really want to go for the rock bottom price installation, right? Well, there's that is a double edge. You get a cheap installation on the front end, but potentially hazardous on the back end.
Right, and that's another thing that can just contribute in the baseline, because if you're one of those people who's looking for the absolute baseline installation, you're probably one of those people. I don't want to make generalizations, but you might also be of the mindset that once you have it on your roof, it's there, you can forget about it, it's generating. And that's an issue where it's almost an investment in your safety to have regular maintenance done and to regularly have your system looked at, or else, you're not paying for the system once it's up there, but then you might, if there's any sort of failure, you're definitely paying for that. So it's almost like operations and maintenance is an investment in having to pay less if a system were to fail.
Yeah, exactly. Just like you get your oil changed in your car, if you have an internal combustion engine, right? Every 5 or 10,000 miles, you have to get your oil changed. If you don't do that, your engine will burn up. It will be destroyed. Yep. And then you will have a major expense, $5,000-$10,000 to replace the engine. Same thing with the solar array. It is expensive technology. You want to take care of it so that it's running smoothly and not only offsetting your load, but not causing some catastrophic failure that is going to require a major investment in repairing that.
Right.
So what else should we talk about regarding fire safety and solar, Tim? Anything else on your radar?
Well, I think the biggest thing that was on the radar is just better tracking of it, because like you said, these instances are only happening in low percents of systems, but that's also because there are untold fires that have been caused by solar, and this is not fear mongering, because it may bump that 100% to just something marginally higher than that. But like I said, the U.S. Fire Department has not classified solar fires as solar fires. So, there were the 155 instances that we have known of since 2015. But that's the point. That's just kind of what we know of. So I think alongside, analyzing installations and maintaining installations, there needs to be, or it's time for more concrete tracking of fires, more concrete reporting. And also, when you get a reported solar fire, it's just a reported solar fire. It doesn't mention if it was because a component failed or if it was because of poor installation. I think there needs to be, at least from what I've talked about with Richard, better tracking on what caused these fires. If a fire on a home was started by a solar installation, having that tracked as a solar fire rather than I think it's literally under their other category of what starts fires.
Yeah, and I think it's very hard to determine generally the cause of the fire. I mean, a lot of the evidence does burn up in the fire,
Right.
but more and better tracking would be a good thing. It just allows us to have, more transparent reporting. Everybody is on the same page. I did do some homework on commercial fires, and the largest cause of commercial fires in general in buildings is smoking, right? So employees or contractors are smoking near some flammable material, and the accident happens, a butt gets flicked, and the fire occurs. So that's the good news, is that those kinds of fires aren't happening with solar. It generally is very safe technology,
Yeah.
very tried and true. But I look forward to continuing this conversation with PV Magazine and other colleagues in the industry about ways that the solar industry is documenting safety and making the industry as safe as possible. The lesson is, do operations and maintenance, though. If you buy a solar array for your home or your facility, please get an O&M contract as part of that, and just keep everything as safe as possible. Well, we're out of time, Tim. I want to thank you so much for your time. Keep up the great work at PV Magazine, and hopefully this will be the first of several discussions.
Yeah, I hope so too. Thank you. It was a pleasure to be on. I've never done a podcast before.
Well, thank you, and thanks to everybody who's listening. Let's grow solar.